Alright, I'm recording again. There we go. So, board with solder paste applied, epoxied in place, hot plate at about 230°C. I'm going to set you up here so you have an overhead view of this. That looks pretty reasonable. You want to see this, Jason? Here we go. Removing the cover plate. Dropping part onto hot plate. Reapplying cover plate. Now we just wait for a moment and hope the flux doesn't boil the parts out of alignment. As long as it doesn't drift too far, the surface tension of the solder when it melts is enough to pull the parts into exact alignment. I've soldered a couple of things with good results this way, but sometimes if there's too much flux, I have to abort and reapply and redo. Oh, there it goes. There it goes. And it looks like I got a little bit of bridging, which I'll have to correct manually, but didn't drift too far out of alignment, so that's good. So by taking the cover plate off, the temperature is at 230 Celsius on the plate right now, and I'm cutting power. But by taking the cover plate off, the influx of cold air is usually enough to put the solder into a stable state so that I can pull that off. Let it cool for a moment. Drop it on the microscope plate and see how we did. Let's see how we did. Come on. I need to 3D print a fixture that makes this easier. There we go. Alright, so we got some definite bridging. That's really easy to clean up though with an iron and some solder braid. Sometimes that happens. It's less of a problem on QFN parts and whatnot where there's not that external lead that these parts have. So those parts are much more resistant to that. But on the whole, looks like that one came out perfectly right there. So that one's good. That one looks good. Those two need attention. So there we have it.